Forests regrow 10 times faster than thought. That is the startling conclusion a team of ecologists reached back in 2018. They were standing in the middle of a burned scar in Oregon, a place that felt more like a moonscape than a woodland. Imagine the scene: 300 acres of devastation. The air still smelled faintly of charcoal and old smoke. Ash, gray and heavy, coated the ground like a thick, suffocating blanket. It was a graveyard of blackened trunks and shattered limbs. Yet, as they looked closer, they saw something impossible. Within just a few short months, vibrant green saplings were already knee-high, piercing through the charcoal crust. That shouldn't happen. Not according to every textbook in the library, not according to everything they had been taught in graduate school. The biological clock of a forest is supposed to move slowly, measured in decades and centuries. Here's the thing. The team had expected the regrowth process to be a grueling, slow-motion struggle that would take decades to show real progress. Instead, they found dense, lush patches of young trees in just 2 years, and these weren't just any trees. They were Douglas firs, which are notorious for being some of the slowest starters in the entire forest. They are the cautious ones, the late bloomers. To see them thriving like this was an anomaly. It was as if something was giving them a turbo boost, a hidden catalyst pushing them toward the sky at a speed that defied traditional botany. Driven by curiosity, they dug deeper. They literally dug into the earth, pulling up soil samples that revealed a hidden, invisible player, a fungus called rhizopogon. Now, to the naked eye, it looks like nothing more than thin, white threads. But these threads form a vast, intricate web beneath the forest floor. This wasn't just any web, it was a living highway. A biological network that connected roots to roots, creating a subterranean social system, and it was doing something that no scientist had ever documented before. The fungus wasn't just helping the trees absorb water, it was actively transferring nutrients at lightning speed: carbon, nitrogen, phosphorus. All the essential building blocks of life were being shuttled across the soil, and the most incredible part, it wasn't doing it randomly. The fungus was targeting the youngest, most vulnerable trees, the ones that needed the help the most. It was almost like a parent feeding a child, ensuring that the next generation survived the trauma of the fire. But wait, there's more. As the team analyzed the data, they found something even stranger. The fungus was selective. It wasn't helping every single species that happened to be in the area. It was prioritizing the ones that mattered most, the keystone species. These are the trees that hold the entire forest ecosystem together. The ones that create the critical habitats for birds, insects, and mammals. The ones that prevent soil erosion and store massive amounts of carbon for centuries. The fungus was essentially acting as a forest architect, strategically rebuilding the foundation of the ecosystem. Here's why this changes everything. For decades, our reforestation programs have focused on a very simple, linear logic: planting trees. We plant millions of them, often in neat rows, and we count the seedlings as a victory. But what if planting isn't the real answer? What if the true key to restoration is happening underground, out of sight? What if the secret to healing the planet isn't found in the seed, but in the soil? To prove this, the team ran a controlled experiment. They took 2 separate plots of land. In the first plot, they planted saplings alone, following the standard industry protocol. In the second plot, they planted saplings and inoculated the soil with rhizopogon. The results were staggering. The inoculated plot grew trees 3 times faster than the control group, and it wasn't just about speed. These trees were healthier, they were taller. They were significantly more resistant to drought and disease. They weren't just surviving, they were thriving. But here's the kicker. This fungus isn't some rare, exotic specimen found only in one corner of the world. It's everywhere. It exists in forests across North America, throughout Europe, and across Asia. It has been there for millennia, quietly managing the earth beneath our feet. Until 2018, no one had connected the dots. No one had asked the right question. What if the forest isn't just a collection of individual trees competing for sunlight? What if it's a single massive, living organism? And that's when it hit them. The implications were massive. If this fungus could accelerate regrowth to this degree, it could change the way we fight climate change. It could redefine deforestation efforts. Even urban planning could be revolutionized. Imagine cities using this technology to grow green spaces in a fraction of the time. Farmers could use it to restore degraded land that had been stripped of its nutrients. Conservationists could use it to bring back ancient forests that we once thought were lost forever. But there's a problem. a big one. The science is still new, and in the world of academia and industry, new is often viewed with suspicion. Not everyone is on board. Some researchers argue that the fungus is too unpredictable to be used on a large scale. Others say it's too expensive to produce and distribute. And then, there are the industries that profit from the status quo. The logging companies, the monoculture farms, the chemical manufacturers who sell synthetic fertilizers. They don't want a solution that doesn't involve their products. They don't want a nature-based solution that is free, efficient, and self-sustaining. So what happened next? The team published their findings in a peer-reviewed journal. They expected applause. They expected a rush of funding and a global shift in strategy. Instead, they got silenced. Their paper was cited in other academic works, but no one acted. No major reforestation programs adopted their methods. No governments funded the necessary follow-up studies. It was as if the discovery had simply vanished into thin air, swallowed by the bureaucracy of the status quo. But here's the good news. The story doesn't end with silence. A handful of grassroots projects are picking up where the team left off. In Oregon, a small nonprofit is using rhizopagon to restore a clear-cut forest, bringing life back to a wasteland. In Scotland, a community group is testing it on degraded peatlands to soak up carbon. And in Japan, a university is studying how it interacts with bamboo forests to create more resilient landscapes. So why does this matter to you? Because the next time you walk through a forest, I want you to realize that you're not just walking among trees, you're walking through a living, breathing network. A network that's been healing itself for thousands of years. A network that could heal the planet if we only have the courage to let it. But here's the question. Will we? Will we listen to the science? Or will we keep doing what we've always done, planting trees and hoping for the best? The choice is ours. The fungus is ready. The forest is waiting. Support organizations that prioritize mycorrhizal research for a greener future.